Hello, I'm Casey from Denner, USA. I'm here today to show you a hydraulic press brake. This is the Puma series from Denner, USA. This happens to be a 3,600 millimeter by 220 metric ton press brake, or roughly 12 foot by 250 tons. The Puma series machine has a very large open height and back gauge stroke. 40 inches is attainable on most all the back gauges. The machines are normally with a minimum of 2-axis back gauges. So X and R, this machine has a power Z1 and Z2. So these fingers are on gear tracks, can move left and right according to your program. All the motors on the back gauge are made by Mitsubishi. The hydraulics are designed in Germany by Horbiger. All the electronics are German, it's Siemens. And the linear guides, the back gauge fingers are riding on, and these sheet supports out front here, these are made also in Germany by Rexroth. Here are the standard sheet supports on a 135-ton and larger machine. As you can see, they ride left and right on these linear guides. You have 2 chromed bars to put your sheets up on top, plus a metal inch-millimeter scale with a disappearing stopper here to put a sheet down, and front gauge. Not done too often, but it's a standard. All Denner USA press brakes come with segmented upper holders as standard issue. Of course, hydraulic clamping is an option. Even in an American style ram face with clamping bars this wide, like old-fashioned press brakes, that's an option too. But these segmented upper holders are very useful. They act as die extensions, the tools down below here. You don't need to buy a tool so tall. They have quick release plates as an option, or you can use just standard hex head screws to tighten the plates to hold your tool. Currently, this punch holder is set for a European upper punch. However, there is a plate right here that moves like this, and when you move it to the front position, an American die can go up into the holder. So these holders are kind of universal. They take American or European upper punches. Here you can see the standard fingers on a 2-axis or 4-axis back gauge. When I say 2-axis, I mean X, R, the whole bar goes up and down, and then Z1 and Z2. These are on a gear track with Mitsubishi motors on the backside to go to whatever position you program. This position here is step number 1. This is programmable step number 2, and way back here is step number 3. This is your 40-inch position back here. Here is laser finger protection. This is a DSP laser made by Nuova Electronics in Italy. It's a very popular item for us. About 19 out of 20 of our machines have this on it. As you can see, there is a diffuse red laser being emitted from this way, and it's covering 9 holes, 3 in the front of the center line of the bend, 3 in the center, and 3 in the back. In blue, you basically have a rear, a center, and a front zone surrounding a punch tip. You can actually, in any given step of a program, shut off or mute these 3 front holes here, and you create a box forming mode. If you have a side flange sticking up 4 inches, about the height of my finger, and that laser beam hits it, it's not going to stop the ram. The ram will pass the obstruction down to the slowdown point and bend without having to go through a long distance of slow bend speed. So box forming is very popular on this particular unit. Here you see a step motor that controls CNC wedge crowning. This is our lower table. It's our standard table. It's about 4 inches deep, and it's got these micro adjustable clamp plates for fine putting your riser blocks or dies on here square to the upper ram. But in this connection position here, there is a shaft that goes to crowning wedges underneath this table. This is actually an upside down U channel. And in the bottom of the U channel in here are 2 opposing waveform wedges. This was developed by Wheeler many, many years ago. And if this motor pulls on the top wedge against the bottom wedge, it forms a parabolic crown. This is all invisible to the operator. He can change the crowning if he wants to. It's basically an adjustment to 0 to 100% crowning, 0 to 100 on the screen. But almost always, this is something that just happens within a second in between bending steps. CNC wedge crowning. What you see here is a very large C-frame gap. Most of our machines have a 17 3/4 inch C-frame gap to the center of the V-die or the punch tip up above. So on hydraulic machines, you know, your upper piston is placed dead center over the frame, but the table is wider than that frame, about a foot wider on the left and right side. But if you can get a 17 3/4 inch flange, say on a 10-foot machine, a 10-foot long part, you can pass it all the way through and not worry about hitting this. It's very large compared to most other press brakes. You can also see that our linear scale here is attached to this artificial C-frame, which does not move. It has no stress on it. It's attached down here to the frame that never moves, and it's attached up here to the linear scale. What this gives you then is what is called bed referenced ram alignment. And so no matter where you bend along the bed of the machine, left of center, right of center, the left and right pistons are always going to go to the same position. The punch tip will always go into the same position within the V-die. So there's no tapering of the bends. It's a very, very simple solution for ram parallelism. Here's our electrical cabinet on the hydraulic press brake. As you can see, we have back gauge servo amps. These are the Mitsubishi drivers for the motors on the back gauge. All the electronics, all the breakers are Siemens. This unit right here is the ladder logic circuits for double redundancy and safety on the machine. Our laser devices get plugged into this and control all the safety circuits. This over here is basically the motherboard of the controller hanging on the pendant to program the machine. There's a fan up above here that sucks air in, pulls it from the bottom and draws it across everything. If you're in an extremely hot environment, an air conditioner is an option, but this is pretty good for anything 100 degrees and less in a shop. The Puma machines, which is the machine we've been reviewing here, has a standard 21-inch Windows 10 3D control. When you bring up the window to do 3D programming, this is what you first see, a list of programs that you've made before. Let's say I wanted to open up a 3D file and see how fast this can process a part for me. I would go Open Part. Here, for example, is a folder of IGES files. On this machine, I have another folder of step files. It's a Windows application, so you can have many, many folders of parts. Let's pick on this little part here called triangular box. It's asking me what type of metal is this? Is it stainless steel? Is it aluminum? I'm going to say it's steel. And then I'm going to go import. So what it's done now is flattened out that 3D part. It hasn't picked out a punch or a die. We're going to do that now. So if I go Auto and I press Start, it starts looking. It found them already. A green bar on the bottom means it's found a solution. And if you look up here, I have a punch and a die on the top row, and I got a different punch and die on the bottom row here. That of my existing tools that I own, it says both of these will work. And what it really means is it's looking for a V die that matches the inside radius that was on that 3D part I just opened up. So I'm going to say, okay, I like this punch and die right here. So it puts the tool into the picture. If I zoom out, there's your punch and die. Now, if I want to find a bend sequence, I go Sequence down here, and it starts finding the proper sequence that's going to work. And this will keep looking for solutions until I find one I like. It's already found one up here with a green flag. I'm just going to say stop. Good enough for me. I'm going to go use that one. And so now all you got to do is hit simulation. There's 6 bends in this part. You probably can't see that on the little window. And then I'm going to hit play to see just if I like this. Now here we had a very, very slight collision with this finger and the part. You can see it right here. And it paused. I'm going to go stop for a second. I'm going to get that finger out of the way and move this one over. And I'm going to continue and hit play. And the part is complete. I can go to the first bend. I can zoom in a little more. I'll hit play again. So without me talking and processing this part, it's probably a minute. Now this has already picked out the punch and die. It's got a bend sequence. It's got a simulation. This is always available to see by the operator. You can sit here and look at things more closely. You can go to a bunch of preset views up above here. Or he can move the part around on the screen, etc. And after this, all I got to do is hit output, and what that'll do is generate the codes for the machine motors. And then you go to the run screen, and you basically see this step by step as you run the part. Well, thank you for watching these short videos. If you want more information from Denner, go to www.dennerusa.com. Thank you.